Hey everyone, how's it going?
Hello, Thierry, and hey, everyone listening and watching. I guess we'll give everyone like a minute or two to join. But yeah, excited to have you all here.
Yeah, should be a fun one. You got anything fun planned for the weekend, Bastian?
Um, just like going to dinner because of the birthday of my partner. So
Beautiful.
it's going to be nice, but nothing spectacular.
Yeah. Hey Stefan, how you doing? Thanks for
Hey,
joining.
long time no see, Stefan. Actually, so I actually know this Stefan.
Nice.
How about you? Any big plans for the weekend?
Yeah, it's actually my birthday, so I'm gonna
Oh,
head out to Monterey with some family, check out the beach, check out Big Sur, maybe do
Big
some
Sur is
surfing.
beautiful.
Hey, Jorge from Costa Rica. Thank you for joining us from Costa Rica and Modus Mono. Hello. RP Channels, hello from Texas. Eddie, also from Texas. Go ahead and post in the chat where you're joining us from today. I'm curious where you're from. And thank you for the birthday wishes. Okay, so we got someone from Toronto, we got Mexico. We're really hitting all over the map here.
Yeah. Maybe it's also good maybe to tell the people where we are from.
Yeah,
So I'm based in Berlin in Germany.
and I am based in San Francisco.
Yeah. So we're
Okay, so
also all over the world a bit.
we got some, I'm assuming that's Russia, Ireland, Austin, Brazil. We got a lot of Texas. Texas is representing today.
Yeah,
Poland,
nice.
rainy SF. Yeah, Krabash, it's raining. Um, Ontario, India. Another Berlin. Thank you for the birthday wishes. Frankfurt, Germany. Minsk, another Germany. And we've got London. All right, we're going to give people maybe another minute or two to file in here, and then we'll get started. Excited today to be talking about how to build an open source agentic RAG with DeepSeek. So this is going to be a fun one. I know you guys have been hearing about DeepSeek, and we're excited to show you how you can use DeepSeek with Qdrant and also talk to you about the hybrid cloud and the stuff you can do locally with Qdrant. Make sure that your data stays private and you don't have to worry about any data sovereignty or data privacy issues.
Yeah. Especially with open source models like DeepSeek, where you want to host them you're on yourself on your own anyways, and not to connect somewhere in China, for example.
Exactly, right? So we're going to be hosting it via Olama. Everything's going to be local on our own machine. That way you know exactly what's going on with all your code. No black boxes over here. All right, cool. So I see India, I see Texas, Ukraine, and Potsdam, Germany, Islamabad, Pakistan. Very cool, very cool. Okay, Bastian, I think we're going to go ahead and get started here. So thank you everyone for joining us once again. This is Building Open Source Agentic RAG with DeepSeek. My name is Terry Demiba. I'm a data scientist and developer advocate at Qdrant. I am joined today by Bastian Hoffman. He is the director of enterprise solutions at Qdrant. So Bastian's been working with this stuff for a lot longer than it's been called AI agents. So interested to hear his perspective on kind of how the industry has shifted. And my experience is in data science. I used to work for the Department of Homeland Security, and now I'm in LLMs. Bastian, you want to talk a bit about your background?
Yeah, certainly. I have a background in software development and DevOps, but also worked already in pre-sales. So I'm a bit older, so I did like several things there. And I've been at Quadrant for a bit over 1.5 years now, with main focus on our enterprise, how we can eh, keep and make our enterprise customers successful in actually running Quadrant and integrating Quadrant into their own environment while keeping their data secure.
Awesome. Very fun stuff. Cool. So let's dive right in. Thanks everyone for joining us. We got Amsterdam and Canada too. My last shout outs. Okay. So today, as Bastian mentioned, we're going to be talking about enterprise open source agentic RAG with DeepSeek. And this is a really exciting topic for us specifically because RAG in the enterprise has its own set of challenges, right? When you're building a RAG app, maybe for a startup, maybe in your garage, maybe for a smaller company, there are certain considerations you don't really need to worry about. For example, SOC2 compliance doesn't really come into play when you're just prototyping your app. But when you start talking about deploying your app to the enterprise scale, You need to make sure that your app is following regulations. You're not doing anything that is illegal or would get you in trouble. So Qdrant is, of course, fully open source. We love open source over here at Qdrant. We will always be open source. And you can always use Qdrant for free, 1 GB for life. No credit card required. Just head over to Qdrant, sign up, and you'll get that for free. And today, as I mentioned, we're going to be talking about RAG in the enterprise, but to give you a little more detail on our agenda, first, I'm going to talk about the ML implementation. So we're going to show you how to run this RAG app that I've created for looking through contracts as well as tickets for a fictional support company using DeepSeek and Qdrant. And I'm going to talk you through that process. Then I'm going to hand it off to Bastian, who's going to talk about the cloud environment, where you can actually deploy using hybrid cloud and Qdrant locally any kind of project or AI application that you have. So if you're the kind of company that cares about your data privacy, data sovereignty, maybe you're working in legal, maybe you're working in pharmaceutical, maybe you're working with the government, this is the kind of application that's really going to hit for you, because it's going to allow you to do everything you need to do and also make sure that you're hitting all those regulations. And I'll also be able to show you a bit of role-based access control to even kind of pound it in further. So without further ado, let's jump right in. First, I want to talk a bit about the architecture at a high level. So before we kind of jump into the code, let's just wrap our brains around what is actually going on here with this architecture. So what we have here is on this slide, the full life cycle of what happens when you're using this application. The user is going to submit a query, and this query is going to be in natural language, right? Humans talk with words, we don't talk with numbers. So what we can do is we can actually turn those words into numbers using an embedding model. And then once we've turned those numbers into words, we're basically going to be able to give those words significance. So the same way that you can calculate the average height of the people in a room by just asking them, hey, how tall are you? Dividing the total height by the amount of people in the room. This is how we could, for example, find out the average sentiment on something, right? These embedding models are going to take words, they're going to turn them into numbers, and those numbers are going to have significance. Now, the really cool thing about RAG and LLMs is when you submit a query, so for example, if you were to ask, when was Much Ado About Nothing written, the information that contains the answer to that query is similar numbers as the actual query. So basically you have this back and forth system where you can not only query your data, which you've turned into numbers, but you can also generate the response, right? So you can take your unstructured data and actually get insight from that data. So the process here is basically turning that query into numbers, and then we take those numbers, we put them inside of our vector database, and then when the user has a query, we're going to provide that query context, which is going to be taken from our vector database, and then from that context, we're going to have an LLM. In this example, it will be DeepSeek, actually return us the answer. So in terms of components, we've got this contracts and tickets collection, which I will share with you shortly. And we've also got the DeepSeek R1. I'm running the 1.5 parameter because I am video streaming and I don't want my computer to blow up. But there are, of course, larger DeepSeek models, which I'll cover as well. And we're running it via Ollama. And then the vector database is, of course, Qdrant. And our front end is going to be Next.js. So now, if you don't mind, I am going to share my screen here. And you should all be able to see my screen now. Just want to confirm that everything is showing up correctly. Okay, awesome. So the very first thing that we're going to do to actually run this app is we're going to connect our data to our cluster. So Bastian's going to show you how to set up your hybrid cloud cluster, but we actually already have our cluster set up, which I can actually show you here. We have the star charts cluster, the star charts collection in our cluster, just to show you that the cluster exists. And this is actually being done through, if you look at my terminal, I can show you that we're actually doing this through Docker. So I can just quickly kill this and run it again, we have this Docker run command, which is going to allow me to run my Docker. And then I can
Thierry,
yeah.
Sorry for interruption. Can you increase the font a bit? That was from the chat.
Yes. Is this better?
It's good for me. If not, then just put it in the chat again.
Okay.
Thanks.
Hopefully this is good. I can blow this up as well. Let me know if anyone still has issues. So basically here I'm running my Docker command, and this Docker command is going to allow me to actually connect to the Docker server. And then here I'm connecting to our own hybrid cloud. I'm not going to share with you the details of that so that you guys can connect, but Bastion will later show you how to set this all up. So we've got our star charts collection here, and then I have a simple script here that's going to allow us to upload our data to Qdrant. And if we want to take a look quickly at the data that we have here, we have these two different tables, and these tables are super simple because we just simply want to demo what's going on with Qdrant. In a real life use case, of course, you would have many more points in your data, but this is just a demo of real life use case. And then another thing I just want to highlight before we dive in, typically with Qdrant, we recommend having a single collection set up. Here I've created two collections. There's a support collection and a tickets collection and a contracts collection. And I did this just to show you the granularity of the role-based access control. But in practice, we recommend having data like this in one collection, and then just having, for example, a data type field or something like that that would differentiate between tickets and contracts. So here we have the two tables. You can see here in our ticket table, just ticket ID, a company, a subject, a description, priority, status. And then we have contracts, which are going to be the contracts for these different companies, right? So if we actually take a look at what that raw data looks like, you can see here, for example, here is a contract, and let me just turn my word wrap on and let me blow this up for you as well. So you can see here we have an agreement contract. This is just some mock data to kind of show, hey, if you worked at an enterprise in a support system, you might have some contracts. And then in conjunction with the contracts, we also have these tickets where if you look at the tickets, you're just going to see, okay, for example, there's users at Delta report that the application is responding slowly, backend issues. So you can see here we have these two data sets that are basically just going to be a simulation of an enterprise use case for a support team. And we're going to take these data sets and we're going to upsert them into Qdrant. So that's going to be the first step, is just running this code to upsert it into Qdrant. And then if I go back to my Qdrant UI and I refresh this, we'll see, okay, we have my contracts and my tickets, and this one's still populating, which is why it's still empty, but we'll come back to that. So now we've uploaded our data, and I also wanted to share with you the actual application that we're running today, which is our DeepSeek Agentic RAG. So I can pull that application up at my localhost, and we can try the demo. So what you can see here is basically, and we're going to share this link with you as well so you can follow along. You can see here, if I say show me alpha tickets, sorry. And we're just going to select 3 different roles, A, B, and C. And while that is going on, I'm actually going to drop the link to this repo so that anyone who is with us can follow along if you're interested. So the big thing to note with this repo is you are going to need to add your environment variables from this file that I have given you here. I've given you these variables that you can use for the demo. I'm going to kill these variables after the demo, but you can use this to run the demo. The only thing you need to add is a Qdrant URL, which you can get from going to Qdrant. If you sign up, go to your cluster. I can actually show you this. Sorry, one second. If you go to your cluster, you'll be able to get your URL, and that's the only secret that you'll need to add to run this demo. We've given you all of the other. So here's going to be your endpoint, and this is the only thing that you're going to need to run this demo, and you're just going to want to insert that into the sample file at the very top as your Qdrant URL, and everything will run. So now we have this app, and of course, I'll be around. So if you have questions or you can't run it, don't worry about it. I'll be here. So we have this app basically that is our RBAC demo, and I believe we have it here. I'd run the query, but I can just run it again. Show me all alpha tickets, and we'll select these three roles, which are account manager A, account manager B, and the head of support. So we can see here first the documents that are actually retrieved by Qdrant. So this part is all being done locally through the Docker that I showed you earlier. And basically what's happening here is we're retrieving these documents, which are, we asked to see all the alpha tickets, and we can see here that the head of support and account manager A were both able to retrieve all three of the alpha tickets. However, if we look at account manager B, they were not able to retrieve the alpha tickets because they don't have access to those alpha tickets, right? So we set up this role-based access control situation where account manager B has access to Badger and Charlie, but they don't have access to alpha. Account manager A has access to alpha and Charlie, no access to Badger. And then account manager C has moved to the graphics team, so their access is revoked. And you have the support agent that has access to all tickets. So what you'll see is if we just take a look, for example, at account manager B's answer, who I'll remind you doesn't have access to alpha. First, we query, and you can see this is a DeepSeek working, so it's kind of cool to kind of see its thought process here. I need to figure out all alpha tickets, so it finds the tickets, okay, and it responds, and it's like, no, there's no alpha tickets. That's because account manager B doesn't have any access to alpha tickets, right? So what we're demoing here is multiple roles being able to query the same database, but if we look at account manager A, they're like, hey, look, there's these three alpha tickets and also the delta ticket, which they found, but they have access to everything, right? And you can also see account manager A was able to see these account tickets, right? So this is just a demo to show you kind of role-based access control using Qdrant and DeepSeek. And if we want to kind of dive back into the code, dive into the components, basically, I will show you briefly how this app works, and then we'll get back to the slideshow. So this is a Next.js application that is using Qdrant. So how Next.js works is basically we have this file called the app page.tsx, which if you're familiar at all with building a website, this is almost like the index.html of your website. And what I've done is I've come in here and I've created these API routes that allow us to analyze, check the collection, create the collection, embed, get the meta-analysis, all of those different things, right? So basically, using Next.js and Qdrant, you can actually build a full stack application that implements role-based access control that you could deploy either locally, as I'm showing you here on the local host, or you could also deploy it online on the internet, like I've deployed it here at quadrantRBAC.com. So the idea here is we're showing you, okay, if you need to make sure that you take care of your data sovereignty, your data privacy, then the local deployment might be the best option for you. You can build an application for your internal use case using Next.js, also using Qdrant, and also with that role-based access control. And everything will be local. The only data that gets out is going to be telemetry data, because when Qdrant connects to you, we're not actually looking at any of the data that you are using. So I'm going to stop sharing my screen and go back to the slideshow and kind of talk about some some ML pipeline optimization. So when you're thinking about your ML pipeline, first you want to think about what LLM you want to use. So DeepSeek has a variety of different models, and then in the variety of models, there's also different quantization levels, there's different parameter levels. So the very first thing you have to do is figure out, hey, what are my resource constraints? So for example, today I'm running this on a Apple M2 Silicon chip. So I used one of those smaller models because not only am I running this in the background, but I am also streaming. So I wanted something really lightweight. Obviously, the answers aren't going to be as in-depth when you're using a more lightweight model, but you're still going to get an answer, right? So you have to kind of pick and choose depending on how much resources you have, how quickly you need the answer, how much being accurate matters, right? If you're running an application that's going to determine whether or not someone has cancer, you probably want to focus more on accuracy than someone who is doing recommendations for e-commerce, where you just want your recommendations there as soon as the page loads. So make sure that you're using the correct model. And then furthermore, DeepSeek has differentiated their models in terms of there's a coder model and there's a chat model and a combined model. So if your use case is coding, of course, use the coder model. If it's chat, use the chat model. If it's a little bit of both, use that combined model. And also just keep an eye out for the news, because DeepSeek has been moving pretty quickly. So they're releasing new models pretty frequently. They might have something new even by the time that this webinar is over. And in terms of embedding and chunking strategy, the thing you want to focus on here is, once again, make sure that you are playing to your use case, right? So you want to make sure, of course, that you are embedding all of your documents. Chunking might not be necessary. If you have really small documents that you can just upload manually, or I shouldn't say manually, upload without chunking, that might work for you, right? Chunking is something that comes in when you start to see the different documents in your vector database starting to become a little too unwieldy for your model. And then in terms of model embedding, you also want to make sure you're using the right embedding model for the use case. We're working on some tools that'll help you figure out the right embedding model to use, but just make sure that you're not just using whatever comes out of the box, because you might get results that you're not happy with, and then you'll be confused. That's something that I've experienced myself. And then configuring Qdrant. So not only configuring Qdrant, but also making sure that your LLM is configured to work with Qdrant. So if you go back to that demo, sometimes you'll run a search and the correct documents are retrieved to answer your question, but the LLM won't answer the question correctly. And that happens for a variety of reasons. LLMs aren't terribly consistent, even when you put the temperature to 0. They just won't always give you the same answer, right? So you have to make sure that you've built out a pipeline where when it doesn't give you the right answer, it's not because it's not able to process the documents that you retrieve correctly. So a lot of the troubleshooting I do is with people that say their search doesn't work, but when we look under the hood, we see that the documents are being retrieved correctly. The LLM simply isn't converting those documents into the human readable answer that the user wants at the end. So make sure that you're making sure that your configurations are good there. And we have tons of documentation on that. We'll also provide that to you in the follow-up message for this video. And then, of course, just make sure that you're taking advantage of all the features that Qdrant has in terms of on-disk storage. We just released some HNSW optimizations. We've also got Grid Store that we just released. We've got basically custom built functions to make sure that your search is as great as it can be on Qdrant. So make sure that you're taking advantage of all of those tools as well. So that is going to be it for the ML implementation side. I am now going to pass it off into Bastian, and I'll also hop in the chat. So if you have any questions, feel free to ask. Bastian?
So maybe, Thierry, do you want to do like 1-2 questions in between before we continue?
Yeah. No problem.
Because there were quite a few interesting ones. I think one thing from Mahesh at the beginning was that we can quickly answer, because he was a bit unsure, like seeing this demo, what actually data is stored in Qdrant then. Are these like documents or objects? Maybe we can do like a 5-sentence answer for that.
Yeah, so Qdrant's pretty flexible in terms of what it will let you store. And I will also just share my screen really quickly so that you can actually see what I'm doing here. Oh, sorry. So this is my collection here for contracts. And I'm going to show you another collection later, because this is obviously a demo collection, but this is just one way that you could set up a collection, right? We've got this different, what you could think of as columns in a tabular data, where we've not only given the contract ID and a summary, we've defined whether the manager A has access, and then there's also this metadata that we have, along with service detail, terms, keywords, date signed on, and expired on. Now I want to show you another cluster so that you can see a different way that you can set up your data for a multimodal case. So we have this H&M clothing data set. Sorry. We have, sorry, I was in my head. We have the Midjourney data set where you can see here the difference. Here we're storing a file name, an image URL, a name, and then the style of the image along with the image. So if we actually take a look at the graph here in Qdrant, we can do sample 50 tree is true. And if we run this, what you'll see is we can actually look at the images in the data, right? So here, the data is images. In the previous example, the data was contracts. But the idea is using Qdrant, you're going to take that unstructured data and be able to find out how the data relates to each other, right? So I'm using images here to show you how Qdrant works because it might be a little easier to grasp in terms of the data. Here we have the style of the picture here, which is going to be very unrelated from the style of the picture here. But if I have the picture closer to here, it's going to be more related to the here. So going back to our contract data, you can imagine similar contracts would be closer to each other. And you can put the data in that you'd want to. So for example, we might have an image of the contract or the PDF of the contract that we'd want associated with that data as well. So Qdrant's super flexible in terms of what you can store. You can store not only your vectors, but you can also store that metadata as well.
There was another question about like the choice of Next.js as a front end. Just to clarify, this is just a demo application. Qdrant is agnostic to what kind of tool you are using there and how you develop your applications around Qdrant. It's also agnostic to the embedding model and LLM you are using. We just choose here DeepSeek as one example, and we build a Next.js application around it as one example, but you can use for whatever you want to query Qdrant and to integrate with it.
Yep, exactly. Thank you for that. And I'm using Next.js simply because I think it's the easiest framework to get started with. The fact that you can just do npx create app, it's just really easy to get started.
Yeah. And then there was a question about open source embedding models, using them instead of a paid one. Do you have we were using DeepSeek now and hosting it locally.
Yep.
But are there maybe other recommendations that you can?
Yeah. So for embedding specifically, I would recommend FastEmbed if you're using Qdrant, and that is our embedding model provider library. It's built specifically to work with Qdrant. We have quantized embedding models that you can run completely locally. That's what I would recommend in terms of embedding models. If you're talking about other local models that you can run, Mistral has always been fine for me. Llama is also fine. It really depends on the task because if you're familiar with these SLMs that are coming out now, there's a lot of smaller models that are super effective at distinct tasks. So if you have a distinct task, you might not even need one of these bigger DeepSeek models. You can use an even smaller model. But for embedding specifically, FastEmbed is going to be the place you want to go. And I see a question asking if there's different embedding models. Yep. FastEmbed supports embedding models from Sentence Transformer, BGE, BAIE, Nomic. We've got it all.
Yep. And FastEmbed is like a library to make it very easy. But even if you have models that are not supported by FastEmbed, you can still use them with Qdrant. But then you have to write like the code a bit more yourself to connect the results from your embedding library, embedding model to Qdrant. You have to do a bit more work.
Yeah.
I know there are other questions, so maybe one or two here you can also answer in the chat, and then we'll have time at the end.
Exactly.
Go through more of them.
I'll be in the chat. Don't worry.
Keep them coming. Keep them coming there.
Feel free to reach out to me on Twitter, on LinkedIn, anywhere you can find me. Ask questions. We also have a Discord where our CTO is super active, so head in there. I'll head off. Thank you, Bastian.
Yeah, talk to you later. So Thierry already showed how he was building like his application, running his DeepSeek embedding model locally, in this case on his laptop. You can think about in a more productive use case, you would run this maybe on your own AWS account somewhere, on your own VMs, in your own other cloud provider accounts, or maybe in your data center. And he already showed a bit that you can also run Qdrant locally easily. And I want to dive down into this a bit to tell you the different ways we can support you with that. Of course, Qdrant itself as a database technology is open source. So by definition, you have the freedom to run this everywhere you can. But we also have a Qdrant Cloud product that can help you with the operational tasks of it so that you don't have to care about things like highly available setups, zero downtime upgrades, backup and disaster recovery, replication, all of that on your own. And this cloud platform is available in 3 different deployment patterns. So what it gives you is central interface that you can use to manage all your Qdrant database clusters and collections for different use cases. And then it gives you exactly the production readiness features that you would expect to easily create, upgrade, and even delete the clusters if you don't need them anymore, but also to horizontally and vertically scale them up with ease or down. It has functionality in there to automatically do on a multi-node cluster rebalancing and splitting up of the shards so that you don't have to care about that, and you can focus on the actual implementation of your application. And of course, it comes with features like zero downtime upgrades, auto healing capabilities, monitoring, log management, alerting, backup and disaster recovery, role-based access control, and so on. And the 3 deployment patterns are there so that you can choose where to run Qdrant in such a setup depending on your needs. So on the top here, you can see we have our managed cloud platform. That is a typical database as a service platform where you can sign up, you put in your credit card details, you say what kind of Qdrant database clusters you want and need, and then within a few seconds you get started, and we host the Qdrant database for you on our infrastructure in a secure way. You configure your API keys with robust access control. You can switch on single sign-on if you want to for your organization, and you get a URL, and then you're off to go. And we take care of the rest. This is fine for a lot of use cases, but for other use cases where your data is more sensitive, and these are usually the use cases where you also want to run embedding models locally in your environment and not use paid ones that are hosted for you somewhere, you can also decide to use the same platform to run Qdrant databases, not on our infrastructure, but on your infrastructure. And the one I'm going to show you afterwards in the demo is called Hybrid Cloud. And it kind of gives you the best of both worlds and the ease of use of a managed service, but with the data security and sovereignty that the databases run securely and isolated on your infrastructure, and no other third-party vendor but just has any access to the databases themselves. We also have a solution called Private Cloud, which even does not have any connection to us, so that everything is completely isolated. There you don't have the functionality of a managed service where you have a nice dashboard. We receive telemetry of the databases so that we can proactively help you. But if you have use cases where you really need an air-gapped solution, that's also possible with it. Let's focus a bit more on hybrid cloud. So you can see here on the slide a small architecture diagram. If that is too small to read on the slides, I apologize. It is also available. I'll share the link afterwards in our documentation, and there you can see this in a bit bigger. So the way hybrid cloud works is you use our cloud management control plane to manage all your database clusters, and then you can attach any kind of standard compliant Kubernetes cluster that is running on the infrastructure of your choice. That could be, for example, something that runs on your AWS account or Azure account or Google account or DigitalOcean account or whatever cloud provider you're using. It could be something that runs on bare metal in a data center where you have servers. It could even be a Kubernetes cluster running locally on your laptop if you wanted to. And you can connect this then with a simple installation command to our cloud, so that you can then manage databases from there. And the databases themselves run then on your infrastructure using your storage, using your network, and using your compute instances. And they are isolated so that neither we as Qdrant nor anyone else outside of your organization has any access to the databases. But we receive the necessary telemetry to give you the ease of use of a managed service and to be able to proactively help you. So let's look into this in a bit more detail, how you would set this up. And let me switch to my screen. So First of all, I'm going to put this here into the chat. This is the link to our documentation. And it gives you all the details about like the architecture that I just talked about, including the architecture diagram, which is then a bit maybe easier to read. And also, of course, all the setup instructions and information for all the major different cloud providers, like, for example, let's pick here Google, what you need to do in order to create a Kubernetes cluster that has persistent storage and is ready to be used to run Qdrant databases in there. For the sake of the demo, what I chose to do is I created a small Kubernetes cluster at DigitalOcean in one of the accounts that is not connected to Qdrant, that is just I own. And I created the cluster beforehand just because it takes like 2-3 minutes and we don't want to wait all for that. I kept it as a defaults, and we can also look a bit in the cluster itself. And you can see it has, in this case, 3 VMs in it, and each VM has, we can see this kind of here, 4 CPUs and 8 GB of RAM. This is just, I clicked this together with the defaults. I also downloaded a configuration file here, a kubeconfig file, so that I can easily access this from my laptop. And you can see this is the exact same cluster here that I have available, that I can access from my laptop, which is running on DigitalOcean with like the 3 nodes you can see here. So let's have a look at how we can connect this otherwise empty Kubernetes cluster. So it just has some system pods that come from DigitalOcean itself. So for example, to provision storage automatically or load balancers, how we can connect this to Qdrant Cloud. What I already have here is an account at Qdrant Cloud. You can see I also have some database clusters already in here, but let's, for the sake of it, say we want to onboard this Kubernetes cluster here as a new way to run Qdrant databases. For that, we can go here to Hybrid Cloud and add a new Hybrid Cloud environment. Each Hybrid Cloud environment maps to one Kubernetes cluster. Fairly simple. I have to give this one a name. So let's call this DigitalOcean Kubernetes cluster. And then I have to choose the namespace where the Qdrant components should be deployed into. If you are not that familiar with Kubernetes, namespaces is kind of like a organizational structure, like a folder structure within Kubernetes, so that different applications can be in the same environment, in the same cluster, without influencing each other. So I'm going to call this one Qdrant. And then if I want to deviate from the defaults, I also can configure how the Qdrant databases can consume storage in my Kubernetes cluster. We are using standard Kubernetes abstraction for this. For example, storage classes, you can see DigitalOcean comes with different ones, with different also file system. And I want to configure like the default one that just gives me block storage for the databases. And I'm also going to use the same so that I can create volume snapshots afterwards from them. There are tons more configuration options that you need to use in enterprise contexts. For example, if you want to not use our container registry to pull all the container images for the Qdrant database, for example, but your own registry, this is all possible. So let's create the environment. And as a last step, we generate a small installation command for you. The reason for that is that we don't want to create something where you need to give us access to your cloud provider APIs, because that's probably security-wise not a good idea. Instead, we generate you an initial command that you have to deploy inside of your Kubernetes cluster. And this will then create an outgoing connection to our infrastructure so that you can then manage all the databases in there. And this outgoing connection will then not transport any data that's securely on your side, but transport the necessary telemetry to allow like all the management functionality. You also only have to do this once, and then the whole life cycle of everything can be used and can be decided through and configured through the cloud platform you are seeing here in a very easy way. So let's actually maybe have a bit of a look what's being deployed here. And let's maybe make this list a bit smaller so that we can follow along. And you can see there here we are deploying currently a couple of like a Kubernetes operator and a small agent that then manage all the database for you. So a couple of small components and a small monitoring stack to get the necessary telemetry that you can be sure that your database also works correctly. So now that this is onboarded and done, I can start creating Qdrant databases here inside of my Kubernetes cluster running on DigitalOcean. I can create one database cluster or multiple ones, however I want. And the databases are created the exact same way as you would create them if you use our managed cloud product, where the databases run on our infrastructure. And this can even live side by side. So you can create, for example, development and staging clusters that don't have any live data in there that run on our infrastructure, and you can quickly create them and also turn them down if you don't need to. And you don't need them anymore. And maybe for the production clusters, you can put them then on hybrid cloud on your infrastructure. So we can see here, I could run things on, for example, one of our AWS regions that we offer here, or I could choose to create a database on my DigitalOcean Kubernetes cluster that I just onboarded. And for both worlds, creating databases on our infrastructure or on your infrastructure, you have the exact same functionality. You can choose the Qdrant version you want to deploy. You can configure things like how much memory the database should get, how much CPU the database should get, if you want to have a highly available setup or not, and how many nodes you want to have in the cluster. So since I have a small Kubernetes cluster, let's keep this actually a bit smaller here. You can always scale this up or down afterwards, so you're not locked into what you're choosing. You can just get started, ingest your data, see how it works, and the more data you ingest, then also you can scale up dynamically. So let's create the cluster. And what you can see happening now here in my Kubernetes cluster in a few seconds, that this will now create a new Qdrant database and start the necessary containers. And once this is done, I can start using it and I can start ingesting data and hooking it up then, for example, to my embedding model and to my Next.js application or whatever your application you're using to then also actually query data and create value. So this is going to take probably another 30, 40 seconds. Let's switch back to showing you the cluster that Thierry actually used before. So you can see here, because it's already ready, so you can see here what version it's running on. You can see the status that it's healthy. You can see like memory usage and CPU usage of the database. You also have like metrics available over time. You can create backups of this database and create schedules for these backups if you want to. You can at any point in time also restore one of the backups. And yeah, you have additional configuration options for more advanced use cases. You can see here in the endpoint, there is actually an IP address. This IP address is here because I, when setting this up, chose to create a publicly internet-facing load balancer for this database cluster, but it's up to you how you expose the database. You can keep it internal to your Kubernetes cluster. You can create an internal load balancer within your VPC, or you can create a public internet-facing load balancer without a firewall, however you need to. And once you actually then, in this case, have access to the database and like since this is public facing, you can just click on it and I'm already logged in. So that's why there is no one asked me for an API key. You can see here the contracts and ticket collections that Thierry was using before with all the data in there and the vectors in there. Since this whole system is running on your infrastructure, it's of course also possible to connect it to your own monitoring systems. So all this data is very transparent, and that's also what I did beforehand to show you. So I have a bit, for example, for like a monitoring system that like you could be using, I'm using Grafana. In this case, it's actually Grafana Cloud. And in here, you can see I have a small dashboard. Let's make this a bit bigger. And I have like two different Qdrant database clusters in here. And this is actually the one you are seen here with like the three with like the 2 nodes and 3 different collections in there, and you can see all the same metrics here also over time, and actually much more metrics about like how your collections are configured, how sharding works in your cluster, if the nodes are up and running or not, and of course all of that also over time, including CPU usage, network I/O, and so on. So we expose a lot of data then as well there. If you want to have that in your own system, it's all possible. But you can also access this through the Cloud Console directly if you want to. And last but not least, I also want to show you the parts of the row-based access control. Let's actually switch to another cluster here that I prepared beforehand because it has a bit more data. Because role-based access control, Thierry showed this a bit on the logical level, where different actors, different users of the platform were able to access different data. But it not only works on the logical level in the application code and together with the database, but it also works on an actual access control level in the database. So what you can do, since in Qdrant Cloud now, you can create new API keys in here. And API keys can not only be API keys that allow you full admin access to the cluster. So let's actually open like also the dashboard for this database. It has 2 collections currently, and I'm logged in as an admin. You can also create API keys that have only limited access. For example, if I create a new API key, let's call this a test key, and I chose to not create a global cluster-wide key that allows all manage and write operations within the cluster, but maybe a key that is limited to a certain collection. Let's, for example, take the benchmark collection, and let's only allow read access. And I even could limit within the collection access to only certain vectors because of payload filters, but let's maybe choose a full collection. And I create this API key, and I'm going to copy it. And I'm going to use this now here in my database UI. You can see I suddenly only have access to the benchmark collection. So even on the database access level, you can also already restrict access, not only on the logical application level. Yeah, this was a bit overview about like the security aspects and enterprise aspects that we have inside of Qdrant Cloud and Hybrid Cloud. If you want to get started with it, it's very easy. You can create the account for free. For Managed Cloud, you even have like a free tier cluster with 1 GB of RAM that you can just create and don't even have to pay for. And with Hybrid Cloud, it also starts at a very low price point for small clusters. So it's very quick and easy to get started there. And if you have any questions, yeah, put them into the chat, and we are happy to answer them. And let's go maybe back to the slides and go through them. Yeah, so this were my notes about what I wanted to show in the live demo. Thierry, are you still there?
Yes, I am.
Do we want to start off with the discussion points, or you probably have a better overview about the questions that are there that we can answer?
Yeah, so we've been having some questions in the chat that I've been answering. One question I would ask for you, if you don't mind, is just, in your opinion, what do you think is the biggest difference between hybrid cloud versus the standard cloud?
Feature-wise, the difference is not a lot. There are slight differences in terms of like how load balancing works, just because it's in your infrastructure and not in our infrastructure. But feature-wise, you basically have the same capabilities. The big difference is, where do the database run? Do they run on infrastructure that we own and we operate everything for you and you don't have to care about this? Or is it on infrastructure that you manage and provide, and we and the platform just care about managing and can help you managing the database on it?
Yeah.
That's a big difference. Otherwise, the functionality is the same.
Yeah, cool. And then there was a question in the chat asking, what's better, Llama Index or Llama Index or LangChain? My personal opinion is that they're pretty interchangeable. I think Llama Index is easier to get started with. LangChain is going to be a higher cliff, but I think once you master it, you have more capabilities. And in addition, you also get access to LangGraph. You mentioned that Llama Cloud is coming out, which I know is an offering of theirs, and I bet that things are going to change when that comes out, but I don't have any experience with Llama Cloud.
Yeah. There's also an interesting question that was in there for companies that already use Oracle, other databases, MySQL, Postgres, MongoDB, Elasticsearch, OpenSearch, or something. What would be a reason to move to Qdrant, and how would you even do that? Of course, as with everything, it depends. The benefit of Qdrant is that it's like a database that is very dedicated to storing vectors in a very efficient way, so that you don't overpay on resources. And then it's very efficient in finding similarities between vectors, which you need for applications like these AI agents, like semantic search, like similarity searches and stuff like that. And this, even some of the more traditional multi-purpose databases have also introduced vector capabilities in there, but at some scale. So if you're storing like 1,000 vectors, it usually doesn't matter. You could even keep them in memory. You don't even need a database for that. But if it grows larger and larger and larger, it actually can be very much more cost efficient on the one hand to have store this in a dedicated vector database like Qdrant. And since we focus with Qdrant completely on storing vectors and vector search, we also are on the forefront of features when it comes to, for example, advanced filtering on payload indices, using GPUs for indexing and stuff like that, that more traditional databases don't have. So kind of like two answers to that. Anything to add from your point, Thierry, there?
No, I think you covered it all.
Okay. Do you have another question that you wanted to answer?
So one question I'd like to answer, I think that's interesting to ask. I see a lot of people in the chat saying Qdrant versus Milvus, Qdrant versus Chroma, Qdrant versus all the other vector databases. From your opinion, and I'll talk about my opinion as well, kind of what do you see as the difference between Qdrant, Chroma, Milvus, Pinecone, all of the competitors?
It depends. Like every competitor is, and every solution is kind of different. Like one thing is Qdrant is open source. Not every competitor is. Some are, not everyone, and that can be, of course, a deciding factor. Because even if you start using like a cloud platform that does everything for you, you still have the assurance that you are not locked into it, and you always can say, "Hey, it's open source. If my requirements change, I can still run this locally somewhere." That is, and also with open source, you can contribute. There is no, and everything is obvious. Like you can do security reviews on the database, and also that gives you insurance. Another one could be speed. Qdrant is very fast, and this is something we optimize heavily for, ease of use and the performance of the database. And we also have the benchmarks there that where we compare Qdrant to other databases in the field that are also open source, and we also the benchmarks are open source, so you can even replicate them on your own infrastructure if you don't trust us. And Thierry, you probably have like 1-2 more points or so, while I think about the third one I forgot.
Yeah, the big ones that I would point to is just developer experience and also support. So a lot of these tools are, like Bastian said, they excel in place that in certain arenas. Where I think Qdrant really excels is A, like Bastian said, that speed at scale. We have our benchmarks to back that up. And then B, just getting started with Qdrant is a lot easier than with a lot of other libraries. So you can spend time actually building your application instead of connecting pipes. And for me, that's definitely been one big differentiator. And then the other one I would point to is just our metadata filtering. This is something that allows you to basically query across multiple collections, multiple data points at once. And if you're doing something like analytics and you have to go query individual namespaces, it's going to take you a long time. So that is kind of my spiel.
Yeah. So ease of use means, of course, having it easy to use on a production setup, like with Qdrant Cloud, for example. But especially also if you want to try it out and develop against it, you maybe want to have the database locally running somewhere. And there it's literally for a development setup, Docker run one container image, and then you can you can get started and develop against it.
Yeah, and just to piggyback on that, you literally will have to change a line of code to change your application from running on Qdrant local to cloud to a hybrid. You literally will just have to change one line, which is initiating your client and changing the parameters in there. Everything else in your code can stay exactly the same.
Yeah. And we actually had this exact use case yesterday when Thierry prepared like his demo, and he was using like a local Qdrant instance on his laptop, and he changed it exactly to using a hybrid cloud with one line of code.
It was like, okay, I guess, yeah, that's my full day of work right there. Just changing a lot of code. Boom.
Yeah. There was a question from Jorge. I probably pronounced it wrong. I'm sorry about that. Can I also store code? Maybe there's two answers to that. First of all, Qdrant is a vector database. So the main thing you store is actually a vector, which is a derivative of source data. And this can be code, for example. And of course, so yes, but it could also be an image, other text, or whatever, sound, movies even. And additionally, you can also have the additional payload you can store with every vector that you can then use for filtering or directly returning it to the client. And of course, you can also put code in there.
Yeah.
Yeah.
No, go ahead. Sorry.
Anything to add from your side, Thierry?
Yeah, I was just going to say we actually support through Fast Embed Gina Embedding's V2 base code. I can drop the actual language for that. And that's an embedding model specifically designed for code. So if you ever want to check out some coding embedding tasks, check out that. And then I'll drop the link for the Fast Embed supported models so you can see all the models we have supported.
Yeah, definitely. If you have used Qdrant before, but you haven't checked out Fast Embed, check it out. It's a lot easier to interact with open source embedding models than Qdrant.
Yeah. Will we be integrating RAN-X more in the future? I'm not familiar with RAN-X. No. Bastian, are you familiar with it?
Unfortunately, no. That may be because I'm also more from the operational and DevOps side of things.
RAN-X. Okay, so it looks like it's an evaluation metrics library. And yeah, if this is something that people are using for evals, then it should be something that we can use with Qdrant. I don't see any reason why not. I'm not familiar with this personally, but you should be able to take the outputs from, rank evaluation on information retrieval. Yeah, this should, in theory, work with Qdrant. If it doesn't, I'll check it out this weekend and see if we can cook up a little demo.
Yeah, maybe we can put like a nice tutorial on our webpage.
Exactly. For that. Yeah, always love more evals, baby. Especially when we're talking about enterprise and production. That's when you need to really have those evals in there. Someone asked a question about eval that I answered in chat, but also mentioned on the video. With your evaluations, you want to be really careful. First of all, when you're deciding, are you going to use LLM-driven evaluations or are you going to use raw evaluations? So LLM-driven evaluation might be something like, tell me if this answer is creative enough. Something that has basically interpretability there, whereas you might have another benchmark that's like, how fast did this app run, right? You don't need the LLM to tell you how fast it ran. It's just, it ran in 2.4 seconds or it ran in 2.3 seconds, right? So the very first thing is make sure you're using the right evals for your system. As I mentioned earlier, if you're doing a medical application, an eval that would be pretty important is probably precision. If you're doing a recommendation for e-commerce, the eval that's important is probably click-through rate, right? So, but even if your primary eval is precision, you don't want to have that medical app that takes 7 years to run the query, right? Because then no one's going to use it. So you need to find your balance with the metrics that you're using to evaluate the app that actually makes sense for your use case, right? Don't just throw accuracy or faithfulness in there because that might not be what matters for your use case.
I may have now a stupid question, actually, if you allow. Since I'm not a data scientist and I'm not that familiar with like ranking evaluation, is it also connected to things that you do with hybrid search, where you have like a vector-based similarity search and a token-based search with, for example, dense and sparse vectors that we support, and where you have to then rank and combine also both results, or is it something completely different?
So I built a demo using Relari, Rillari and Qdrant. Let me see if I can find a link and drop it in chat, where I was doing literally that. We basically had some mock data from, I believe it was GitLab legal policy. We ran it with sparse model. We ran it with dense model. We ran it with a hybrid model. And then we compared the output for the same queries with those different models. And that's how we evaluated which embedding models, or sorry, not which embedding model, which retriever to use.
Interesting.
Yeah. Okay, I think we're about time here. Is there anything else you want to mention, Bastian, before we sign off?
Not from my side. If you want to do one more question, I think we have the time for that. Otherwise, join us on Discord, I guess, right? And
yeah,
we can continue the conversation.
I have one more question in the chat that I'll answer before we sign off. So someone asked, will you be demoing auto retrieval? So basically a tool use? Yes, we absolutely will. This is what we've been working closely with Crew on. We just released a tool using Crew AI to query your Qdrant vector database. And I'm going to be making some content showing you how to use that. So yep, keep an eye out for that, Zalasio. And if you message me on LinkedIn or X, I'll make sure that you get a sneak peek. And then final question. Do you have specific advice to implement efficiently filtering search? I tried it and it slows down the research. Yes, there are a ton of different, it's hard for me to give you specific advice without knowing your data, but yes, there's tons of different techniques you can use for optimization, quantization on disk, changing your EF, changing your M for the HNSW. There's a bunch of stuff. So reach out to me personally, please, and we can talk about that, Jeffrey. Is the title, sorry, go ahead.
I also just answered in chat because like this kind of like 70% reason for if you add filters and it slows down is that you did not add an index for the filter, because you can have like 50 metadata fields and it would be a waste to create an index for all of them because you're just filtering on 2. But if you're filtering on them, you actually have to create a payload index, and then it's going to be fast. It could be something different, but that's basically like the 60-70% reason for that.
Yep. And just to close out, so Droop, the agentic piece is actually basically, so for example, we're working with Crew AI to create these retrievers where you can have an agent do the querying for you. So I know some people refer to that as an AI assistant or different language, but that's how we're referring to the agent, is this idea of having an LLM decide where to query instead of having to do that yourself. And if anyone has any more questions, please feel free to reach out to us on social media. Other than that, thank you so much for joining us. Thank you, Bastian. If you want to reach out to him, you can find him on LinkedIn as well. And of course, join our Discord. We have office hours every other Thursday. We get in there and we talk about Qdrant. So if you've enjoyed this, join our office hours. Thank you.